Good evening, dear students. Today we have idea to look for the polymers and polymer based on the applications. Let us come to my session. Basically, the polymers, it is extracted from the nature, means that the best example is the rubber. And today is the polymers world. We are leading the polymers. Most of the things now turn to biodegradable also. So these are some kind of the applications we are using in the commercial purpose. The polymer name, it seems many plus parts, that is giving the hints to how the name it is turned to polymers. This is the monomer, which is the very basic and idea about the polymers. The word polymer implies that the polymer is constructed from pieces that can be easily connected into long chains polymers. Such a monomer means it's a very unique essential unit. It is connected to the long chain and creating the polymer. The classification of the polymer is based on the behaviors of polymers towards temperature, thermoplastics and thermosets. Thermoplastics and the thermosets plastics are defined, or it is easily to understand. Thermoplastics are materials that can be repeatedly heated, melted and converted to a product. So it can be easily recyclable. That is the name it seems called thermoplastics. And thermosets undergo a chemical reaction during conversion into product. The product cannot be remelted and converted into any other product again. So the thermosets means if you can applying the heat, but there is no output, there is no essential output. So once it is settled, means that permanently it is settled, it's not retained to the original shape. And various plastics, and nowadays we have looking about the plastics, how we are using in the some normal industries, and especially the specialty polymers, engineering polymers and commodity polymers. This is the triangle, it is giving a amorphous and crystallines about the polymers. So basically thermoplastics, it is having some idea about the engineering plastics, polyamide, ABS, polyacetylene, polycarbonate and thermopolysters. Thermosets plastics or polymers, it is having the 5 number of the classification: phenol formaldehyde, ural formaldehyde and MF and unsaturated polyesters, epoxy. Advantages of the using plastics. So how we have using the plastic when compared to the other materials. So the basic property is in light in weight, high strength to weight ratio, wider design freedom, easy processability, low energy required for manufacturing, minimum post finishing, corrosion resistance, low creep, better aesthetic code, wide range of colors. Engineering plastics, which is defined as the family to the plastic that is capable of withstanding high loading for a period of time at elevated temperature, and it is adverse environmental conditions. Engineering plastics exhibits a good balance of high tensile strength, shear strength, toughness, used as a replacement of metals in the main application. This is the very significant point. We have the replacements of the some kind of the normal ferrous or the non-ferrous material, while compared to the high tensile strength, shear strength as well as the toughness also. So the characteristics of the engineering plastics, it's a very useful or very compared to the ferrous and non-ferrous materials: excellent dimensional stability, high mechanical properties, retention of mechanical properties at low and high temperature. This is the main thing, that is the because we have not idea about to using the non-ferrous material or the ferrous material while in the low temperatures, but it is giving guarantee to use the plastics at the low temperature as well as the high temperature also. High impact strength at a low and high temperature. So the low coefficient of friction, high heat distortion temperature, high absorption resistance, low shrinkage and warpage. Property modifications by using the bulk fillers, reinforcing fillers, additives and blends. So bulk fillers, it is having n number of the classifications: mica, talc, calcium carbonate, upsets, metallic powders, graphite, molybdenum. And the reinforcing fillers: glass fibers, carbon fibers, aramid fibers, boron fibers and synthetic fibers. So it is very significantly we have to notify the reinforcing fillers, that is glass fibers and carbon fibers. The carbon fibers as well as the glass fibers, it is most of the things it is used in the now in the very recent composite applications, while in the construction of the aircraft body buildings, or especially the that is the covers, aircraft covers, or the internal structure of the aircrafts. The properties of modified plastics: better dimensional stability, low coefficient of thermal expansion, retention of mechanical property over a much wider temperature range, low coefficient of friction and therefore improvement in wear resistant property, higher stiffness and rigidity, higher impact strength at higher and lower temperature, improvement in flexural strength and modulus, high heat distortion temperature, imparting electrical and thermal conductivity. Major group of engineering plastics. So already we have just seen the three types: crystalline, amorphous, the main thing. While you take it as the crystalline, we are having the polymers, acetals, polyesters. The amorphous materials: polycarbonates, ABS, modified phenol. The ABS, it is a copolymer made by polymerization of centrine and acrylate in the presence of polybutane. The proportions can be vary from 15 to 35% or 5 to 30% butane and 40 to 60% serine. The result is a long chain of polybutane gas with a short chain of poly. So this is majority of the applications that the ABS can be used between -25 to 60 degrees in mechanical properties with varying the temperature. This is the very significant point for the while looking in the ABS. So the -25 to 60, which very good temperature level, because we are not nowadays we are using in the sub-zero level conditions. We are not using in the normal material. We have looking for some special material, but it is the ABS is the best suitable for the sub-zero level conditions. This is having the some ABS having the some kind of the essential characteristics: glassy surface, very low distortion, rigid, very good shock and fracture resistance, good chemical resistance, heat resistance up to 105 degrees centigrade, high dimensional accuracy and stability, good electrical insulation, good flow ability. Blends of ABS. The blends of ABS, first the BC blends, the high impact strength and hardness, that's the mechanical property as well as there are some kind of the normal properties. It is improved HDT compared to ABS, dimensional stability, electrical properties independent of moisture and temperature. Applications: electrical and electronics applications, automotive parts. And ABS PVC blends. Flame resistance applications, electrical application, housing, automotive instruments plants, panels. ABS TBU blends, very high impact strength. TPU contributes lubricity, wear resistance, toughness, low temperature and impact strength. ABS provides increased stiffness and improved processability. Dear students, thank you.